Welcome to our PCS 7 operator training series. We're here to help you master Siemens PCS 7 with quick and easy-to-follow tutorials. Don't forget to check out our other videos for more tips and tricks. And if you find this helpful, please call 2359. I'll show you how to load groups of trends. Let's jump into it. 2405. By clicking into the trend system, I can pull up alarms I created earlier for operators during trending exercises. 2418, for example, here's an alarm I made a few days ago. I can display it now. 2430, one will have a dedicated video to dive into trending later. 2440, the colors you'll see include red, blue, dark blue, yellow, black, and green. Each value corresponds to specific process data or instruments. 2502, briefly, you can disable the trend display by clicking on it. Alternatively, double-clicking brings up the associated faceplate. 2515, since this is a simulation, I can modify the values. For instance, I can set the value to 20 or simulate it to test various scenarios. 2540, by clicking again, I can adjust the process value. I can either slide the value or type it directly. Let's say I type 50. 2554, as you'll notice, the black trend increases. 2607, this trend reflects data from a specific instrument, which in this case shows a warning because it's below the acceptable value. 2619, the admitted value is 0. From an operator's perspective, you can clear the alarm if it's no longer active. 2632, alarms can only be cleared when the issue no longer persists. For instance, this particular alarm was logged on November 15th. 2651, the universal date format, day, month, year, indicates the time of the alarm. 2705, the CG, in this context, signifies that the alarm can now be cleared. Previously, it couldn't because the minimum alarm threshold was 0. 2725, now that threshold has been met and the value reads 50. 2742, if I clear that alarm, if I delete it, it will disappear from here, right? So we have several alarms. If you want, you can acknowledge all of them at once by clicking this button, which is a group acknowledgement. Alternatively, you can clear individual alarms one at a time. 2807, this would be a single acknowledgement. To access it, click the scroll button. Highlight the alarm you want to clear, then clear it. Some alarms are consistent, meaning they're still active, so they can't be cleared just yet. 2832, there are other features here, but statistically, when we discuss occurrences in selection and so on, that will be part of a separate video presentation. 28:45 for now. I'm highlighting this, clicking, and voila, the alarm is cleared from the log file. So normally, if a maintenance technician comes in to check the phase plate, they can confirm everything is okay. 2912 will discuss additional features later, but for now, here's an option to input a note, for example, John, timestamp, and specify reconnected instrument. 2942, click enter, and the message is logged. 2951, if I revisit the instrument here, the alarm will clear automatically afterward. 3001, another feature I can demonstrate, even with some restrictions, is the ability to add another value easily. For example, I can add this value to a group I saved earlier. Let's say this particular current value is minus 199. 3014 now, I'll press Ctrl, click the value, and it will appear at the bottom. "3033, my tag is appended to the list, and my value of minus 199.99 shows up here. 3049, I can save this under a different name. Let's call it Test 2. 3103, I can also add a description. To do this, I type the text, press Enter, and later click OK to finalize it. 3126, this means, for instance, if I'm navigating through any of my graphics, I'll be able to call up either the first operator test or the new test I just created. 3139, I'll click on the play icon, and that will bring up the corresponding display. 3158, besides showing the value, this display also reveals the current state. In this case, it's a simulated value. 3207, essentially, it's a simulation. 3213, each graphic automatically adjusts to show the upper and lower values. For instance, this graphic reads amps with a range of 0 to 5, while others display ranges between 0 and 1. 3233, that's pretty much it. You can move the date up, down, left, or right to review specific values. 6. This functionality also allows you to step back 1 hour to review earlier data. "33, for example, you can identify when a value changed, say, from 20 to 50. 3307, this lets you track the black trend value and see what's happening at any given time. In this scenario, the value I'm tracking is the one used earlier. 319, if you look at the display, you'll see it's an interpolated value. Essentially, it's an approximation and is mainly used for training purposes. 3339, I can go back and review data from Sunday. However, Sunday didn't have any tests or activities, so let's check Friday instead, which was yesterday. 34 yesterday at 3 p.m., I started a test with the operator. That was when everything switched to simulation mode, and we began entering values. 34:12 here. You have the option to zoom in by clicking a specific area. This feature allows for a clearer understanding of events within a particular time frame, like 2:45 to 3:10 p.m. 34:29 This zooming capability enables you to pinpoint and observe exact values during a specific period. For instance, you might see values like 277 for 6:29. 35:0 when the last value was always simulated. Essentially, this is a substitute value, sometimes referred to as a battery placement value. 35:16 The system intentionally uses a value like minus 99,190 to help solve calculations. This prevents the system from generating errors based on fake data or causing other issues. 35:41 You also have the option to print this information. You can generate a report or save it for future reference. 35:48 Some plants might prefer to create their own trends manually. Let's say I decide to create a new trend, labeled as Test 3. 36:02 I'll gather data from our archive rather than from real-time sources. In this scenario, I can select a value for demonstration purposes. 36:15 Let's pick something like a gate pit. For example, we might choose a position feedback value displayed on the screen. 36:28 Once selected, I'll apply a filter, which allows me to focus on specific data. For example, using the filter, I might target pit 1. 36:41 After applying the filter, the archive provides three options: pit 1, pit 2, and pit 3. In this case, I'll select pit 1. 37:06 The current value for pit 1 is 34. Once selected, I'll confirm this by clicking OK. 37:14 To make things convenient, I'll name this change Gate 1. Keep in mind that PCS 7 requires specific tagging rules. For instance, it avoids spaces and prefers underscores or dashes. 37:34 In this case, I'll use the format Gate Pit 1 as the tag. Once applied, the trend appears immediately. It's visible as part of the TANAIM value. 37:47 Later, I can demonstrate how to modify this value. For instance, let's say I want to adjust the start and end times dynamically. 37:59 This adjustment might range from 1 minute to a day, or even include specific intervals like 5 milliseconds. 38:12 Now, let's stick with the standard apply. You can see the current value displayed. If I close this and reopen it, I can retrieve my Test 3 display. 38:38 For example, I can modify the value from 34 to something else. Let's pick 60 as the new simulated value. 39 after entering the new value. You'll notice the curve changes, reflecting the updated data. 3913, the system dynamically scales the display, so the previous value of 34 adjusts accordingly. I'll modify this to 50 to demonstrate further. Once adjusted, you can observe the updated value of 52. At this point, I'll stop the demonstration. 3932, I can open the configuration by clicking here. Instead of only having the source and expansion, you can select a time range, clear the start time, and clear the end time. $39.52 in this case. We'll select data from the 15th. I'll go to Thursday, the 14th, and set it to the 16th. Then I'll apply the settings. 4007, the system will reflect the changes, but for now, we'll take it back to the 15th and start fresh from 0. Later, we can apply one of the templates. $40.28, let's open a template where the value was 35. If I click on the right, it will load the data from 17. To adjust the same scale, I'll modify the settings. 4041, if I change the scale, it will display a 1-minute view. Alternatively, I can select a specific time range, like 1 hour, and then apply those settings. Thank you for watching. We hope you found this session helpful in your journey to mastering Siemens systems. But don't stop here. Our channel offers a full range of training videos covering PCS 7, WinCC, S7, TIA Portal, Profibus, and Profinet. 4117 now. We're reviewing data from the 16th. You'll notice changes in the data we worked on earlier. For example, adjustments were made from values like 34 to 60 and then reduced back to 52. $41.38, the same zoom tools apply here. You can zoom in or out using the provided options. Another built-in functionality is the Statistical Analysis tool. 4153, with this tool, I can analyze the statistics for a given period. For instance, I can calculate the average between two data points during a specific time frame. 4208, in this case, I have upper and lower limits, which are displayed on the left and right. 4221, this tool provides the option to view statistics. By clicking the FX button, either at the top or here, you can see the minimum, average, and maximum values. 34. Let me demonstrate. I'll click on FX. Here's what I see. The minimum was 34, the maximum was 60, and the average was 38. Additionally, you can view the deviation when the analysis covers a duration of 30 hours and 41 minutes, which reflects the amount of time between the earliest and most recent data samples. $43.13, the sample count was approximately 822, meaning the system sampled data every 5 seconds during this period, which equals a total duration of 13 hours. $43.44, using the ruler tool, I can view value details at the bottom. It's useful for examining data points before and after a selected time. 4410 The data was downloaded from the WinCC system, specifically from the V2 server labeled as 0102. Data from the process historian can also be retrieved. 4423 For instance, we can access data from 5 years ago. The V2 server communicates with a process historian, a system designed to compress and store large amounts of data for extended periods. 4447 will provide a video specifically about the process historian soon, which will explain its functionality in greater detail. 4503 So now we've transitioned into the graphics. 4509 At this point, we now have a clear understanding of what a personal graphic means. Essentially, it's a manually created graphic or one generated automatically by the system. If you take a look at this example, it's more convenient for some. 4535 However, other users might prefer to build their own graphics. Some plans also utilize more complex ways to display trends. 4553 Essentially, everything is grouped in advance. For example, all flow transmitters, pressure transmitters, and temperature readings are organized into groups. This means that when an operator opens the screen, they can access everything with just one click. Grouped trends streamline access to all temperatures and other parameters. 4619 Using the same feature, the operator can also go back to check historical data, perhaps from hours or even 36 hours prior. This works similarly to using time range buttons, but operates on a different level. 4638 Now, let's move to the trend displayed here from the phase plate. This data is something you can manage locally. It also helps identify degraded or inconsistent alarms. 4650 For instance, one alarm here is consistent and indicates that a higher alarm threshold was violated. Meanwhile, another alarm has been resolved. 4703 We're aware of communication issues with one specific device. This is why we rely on substitute process values. 4718 Here's the section where values are shown. In this case, the limits are 50 and 0. If I simulate the scenario and observe the data, I'll see the value 52 because it exceeds the threshold. 4737 If I simulate a lower value, I expect it to trigger a CG, meaning the alarm will clear. Whether you're looking to enhance your skills in engineering, operation, or troubleshooting, we've got you covered. Our tutorials are designed to break down complex concepts and provide real-world solutions to make your work easier and more efficient. 4758 Let's set it to 45. I'll press Enter. 4805 Now the value is 45 and the alarm has cleared. I already see the CG status reflected. 4820 Let's attempt to create a red alarm. Currently, we don't have a red alarm in the system. Instead, we have only yellow warnings such as high warnings and low warnings. Essentially, there's no high condition triggering a red alarm. 4842 To enable this, you need to configure the PLC program and set the appropriate bit in the block associated with the phase plate. 4850 For the high alarm bit must be activated. However, in this simulation, the bit hasn't been turned on. 4905 Since we're working in this phase plate, we can engage the simulation mode. 4911 in this case, the actual instrument isn't connected. By turning off the simulation, the value will drop to 0. 4933, if I reactivate the simulation mode and revisit the phase plate, I can modify the value to anything I want. Whether you're looking to enhance your skills in engineering, operation, or troubleshooting, we've got you covered. Our tutorials are designed to break down complex concepts and provide real-world solutions to make your work easier and more efficient. $49.52, for instance, I'll set the value to 38. This will remain within the acceptable range. 50 for the system's defined range here is from 0 to 1. 5011, this means I can select any value within that range. 5019, in a moment, I'll demonstrate how to put the system out of service. But for now, let's simulate inputting any value from 0 to 1. These values are predefined in the PLC range. At any given time, a value within this range, such as 1, can be entered. This will cause the green trend line to rise. $50.47, as the green line increases, you'll also see a yellow mark, which represents the warning threshold. Let's simulate a value of 78 to observe this behavior. 51, so the value is at 79. I've already passed the yellow mark, which is the warning threshold. 5106, at this point, I'd expect to see an alarm, especially if I'm looking at the yellow alarm. Now let's confirm. The red indicator here means that the alarm is active and cannot be cleared. However, the earlier alarm, the one displayed here, is different. It can be cleared. So, we have two options, right? I can attempt to clear all alarms, but only one of them will actually clear, which is the one in the middle. $51.45, let's try it. I'm attempting to clear all of them, but as we can see, only one of them successfully clears. Now that we've established this, let's explore some of the system's features, specifically the statistical features. These are incredibly useful, but we'll create a separate video dedicated to them. 5218 for now, let's take a quick look. We have some data already loaded and tested using statistical tools, such as defining the average values earlier. Whether you're looking to enhance your skills in engineering, operation, or troubleshooting, we've got you covered. Our tutorials are designed to break down complex concepts and provide real-world solutions to make your work easier and more efficient. 5245. Why does this matter? It's because these features help us load and analyze trends efficiently. 5252. Let's shift gears and try to put this system into an out-of-service state. We've already noticed some key elements here. If I place the system into maintenance mode, it effectively takes it out of service. D8 in this state, the system will adopt a specific color, clearly indicating it's in maintenance mode. Additionally, if I check the boxes displayed here, I'll see a green indicator, confirming that this component is now officially out of service. There are two main indicators. The first signifies that the system is in simulation mode, while the second indicates the instrument is actively listening to maintenance commands. 5339 now, let's review the impact this mode has on the alarms. 5349, since we aren't conducting any formal training right now, the system automatically brings the values down to 0 in both cases. Here, we can also observe the simulated value from the process variable, PV, when it's manually typed. Whether you're looking to enhance your skills in engineering, operation, or troubleshooting, we've got you covered. Our tutorials are designed to break down complex concepts and provide real-world solutions to make your work easier and more efficient. 5420 Let's release the system back to production. But first, let's examine the data we currently have. Right now, the value is at 79, reflecting the simulated maintenance state. I'll proceed to release this data back into production mode. Once this is done, the system will no longer be in maintenance mode. 5455 Additionally, the data stored in the phase plate can be stopped immediately without any hassle. If needed, we can also navigate back through the historical records or redefine our operational limits. 5514, for instance, let's set a specific limit. One limit could start at 15, which represents yesterday at 7 a.m., and this limit will then extend to today's date, set for 8 p.m. 5538 Once applied, this range ensures that all data within this time frame is captured and analyzed. 5641 Beyond this, we can also simulate real-time data from the phase plate. This data can then be exported to another cell or used to calculate and display various separated variables. We can also integrate this into the current project location. For example, trends like trend 1 or 0 can be visualized here. And as always, everything displayed in this interface can also be printed for record-keeping purposes. 5711 Later, we'll see how the same data functions in other locations or scenarios. For now, we'll pause this video here. Thank you for watching. We hope you found this session helpful in your journey to mastering Siemens systems. But don't stop here. Our channel offers a full range of training videos covering PCS 7, WinCC, S7, TIA Portal, Profibus, and Profinet. Whether you're looking to enhance your skills in engineering, operation, or troubleshooting, we've got you covered. Our tutorials are designed to break down complex concepts and provide real-world solutions to make your work easier and more efficient. Check out our playlists for step-by-step guides, expert tips, and practical applications that can help you achieve your goals. If you've enjoyed this content, please like, comment, and subscribe to support the channel and stay updated with our latest releases. And don't forget to hit the bell icon so you never miss an update. Together, let's take your Siemens expertise to the next level. See you in the next video. In our next session, we'll dive into a presentation on simulating system motors and pumps. This will include how to initialize and start them, how to manage errors, and how to analyze other operational sequences. 5748 Finally, will also address specific issues related to this grain system.